fans. Hopefully you've completed your bell ringer. Solving two-step equations. Remember, we're just doing the opposite. Remember how we drew the line down the middle? And we do the opposite. Same. So my first step, I draw my line down the middle. I add 4 to both sides. That takes away the 4 on this side. I get 3x equals 9. Divide both sides by 3. I get x equals 3. I check it by putting it back in the equation. 3 times 3 is 9. 9 minus 4 is 5. I'm great at these. Let's move over this way. First thing I do, opposite of a positive 3 is a negative 3. I'm going to subtract negative 3 from both sides. That leaves me with just negative 2w on this side. 7 minus 3 is 4. Whoa. 7 minus 3 is 4. Then I'm going to divide this side by negative 2. Divide this side by negative 2. W equals negative 2. Put that back in the equation to check it. Negative 2 times negative 2 is positive 4. Positive 4 plus 3 is 7. Check. All right, let's go to this one. What's the opposite of positive 6? You guessed it, negative 6. Subtract 6 from both sides. This wipes this out. I'm just left with negative 6. Remember, this negative has to stay with this term. This negative 6n right here must stay with that term. 12 minus 6 is 6. So I'm left with 6 and negative 6n on this side. How do I get rid of a negative 6? I divide by negative 6. Divide this side by negative 6. Divide this side by negative 6. I get n equals negative 1. Let's put that back in the equation. Negative 1 times negative 6, positive 6. 6 plus 6 is 12. We got it. We already checked that one too. All right. What's the opposite of negative 3? Positive 3. I'm going to add 3 to both sides. Same. I know you missed that song, didn't you? 7p stays, drops down. Negative 3 plus 3 is 0. So I got 7p equals 0. How do I get rid of 7 times p? I divide by 7. So that one is just 0. Those cancel each other out with p. 0 divided by 7 is 0. Let's put 0 back in and check it. 7 times 0 is 0. 0 minus 3 is negative 3 minus 3. Negative 3 equals negative 3. You got it. All right, over here it says let's draw a hill that goes up and down very fast. So kind of steep, right? It goes up and down very fast. Draw a hill that goes up and down very slow. How about that? Slow, gradual. All right, grab your note packet. Get ready. There's a lot of information in this thing. What we're going to talk about today is slope. You'll be talking about that for a while. Today you'll be able to define slope and understand slope. And slope is a ratio. Basically the change in y, the change in x. By the end of today, you'll be able to find slope of a line. And you'll be able to find the rate of change, but that will be in our next lesson. Part 1 is just this part right here. Find slope. The slope of a line, please read along as I'm going over. The slope of a line is determined by a ratio. Ratio means fraction, right? Ratio means fraction. A fraction, the change in y over x. And it's between any 2 points in a line. And we're going to show you 2 easy ways to do that. The change in y over the change in x. Slope is a constant rate of change. Keyword in there is constant. All linear, it's hard to say, linear has the word in it, and a line, right? It has the word line in it. All linear relationships have a constant rate of change. And basically when someone says slope, that means how steep the line is or how flat the line is. And the y-intercept is the point at which the line crosses the y-axis, so 0y. And that'll be more important in part 2, but that is something you will know. All right, let's get down to it. Check your notes. We'll start right here. A few terms. Linear. Linear means a Straight line. Nonlinear means not a straight line. The rate of change, a ratio of change in x, change in y over the change in x, which basically is right here. And in math, we call that the change in y over the change in x, we call that slope. All right, negative versus positive slopes. Looking at a graph, read it left to right in a book, or just like you're reading a sentence. Positive slopes, positive means plus, right? Positive slopes go up. If positive slopes go up, negative slopes go down. Now, here's a comparison of linear and nonlinear. The word linear has the word line in it. That's how you remember it, line, linear. So this function right here, a straight line, is linear. And this is a curved line, so that would be nonlinear, right? Not a line. This is kind of like a swoop. This line right here, like you drew in your hill, that's an example of a steep line. And this is an example of a shallow line. You'll hear them use those terms all the time. All right, flip the page over. Let's go over the 4 types of slope. This guy, he's going uphill, right? He's chugging. He's trying to puff up that hill. Positive. Puff, puff, positive. Nice. Negative. He's going downhill. He's not even having to work hard. He's just cruising downhill. That's negative. Right? Left to right. So I go this way to this way. He's going uphill, positive. He's going downhill, negative. This guy, he's just flat, 0 slope. And this is like, undefined, help. 0, undefined. So positive, negative, 0, undefined. Nice job. All right. In a second, I'll help you do the first one. You're going to identify each slope as either positive, negative, 0, or undefined. Look at number 1. This goes left to right. It goes uphill, positive. When I say bacon, press pause and fill out the rest of this page. Bacon! Hey, welcome back. Let's go over some of those answers. I did the first one for you, of course. Positive. This one left to right. Negative. This one, it's kind of 0, right? Let's go 0. It's not positive or negative. This one, undefined. 0. Positive, going uphill. This one, positive, going uphill. This one, you've fallen off a cliff. Undefined. And this one, downhill, is negative. I bet you got 9 out of 9 on that. Great work. All right, number 1, another example. You're on the next page. Plot the points, connect the points, and identify if it's linear. Linear means what? Line. Non-linear means not a line. Let's plot these points. Remember, whenever we're plotting points, you're safe. If you go this way, you can probably see me in your mind making the safe sign. So the first point goes left to right, and the second point goes up and down. Way to remember it is you're safe. Safe! All right, let's plot this point. -5, -3. -3, -1. -1, +1, +1, +3, +3, +5. Then you just got to connect the dots. I'll try and draw this as straight as possible here. Like that. All right. Is that line linear or nonlinear? Does that make a line? Yes, it's linear. And what type of slope is this? Uphill is positive. Great job. Let's go ahead and you do this one. Plot those points when I yell out bacon and then come back. Bacon! Hey, welcome back. We're plotting these points now. -5, 3. You probably already had this on your paper. -3, 1. -1, -1. 1, -3. 3, -5. Let's see if we can draw a line between these. If you can't draw a line between them, then it's not linear. Is this line linear or nonlinear? Well, that looks like a straight line to me. It's linear. What type of slope is that? It goes downhill, so it's negative. Negative. You're rocking this. Is this line linear or nonlinear? Let's look at it. Well, it seems to be a straight line, so I'm going with linear. What type of slope is it? Well, 0. Slope goes like that. That's undefined. Positive slope goes uphill, so I'm guessing this one is negative. Negative, which means it goes downhill. It's negative. All right, slope. Pay attention. Slope is basically the rise over the run. You gotta rise up and you gotta run to the Lord. Heard that in church one time. So when you're doing slope, the most important part is to find 2 points on the line. All of these lines already have 2 points identified. Let's look at number 1. So I'm going to basically make a right triangle between this line, this dot, and the other dot. So I'm going to start here. I'm going to go up, and I'm going to go over. See how I connected the 2 dots with the right triangle? And then it's just a fraction. The slope is, well, I go up 1, rise up, and I go over 2. The slope of this line is 1/2, or 1 to 2. It goes up 1, right? Up 1 to here, over 2. Let's draw a right triangle for this one. So we go down. Remember, we're always in the downer up first, and over. So when you look at this one, we went down, right? The slope of this line is negative, so you know your answer has to be negative, right? We went down 2, and we went over 2, right? 1, 2, 1, 2. So the slope of this line is -2 over 2. I could reduce that and say the slope of this line is -1 over 1. This is a negative line, right? So you know your answer has to be negative. Let's move on to number 3. Let's draw a right triangle. Goes up and over, right? Well, it goes up 1, +1, right? And it goes over 2. So our slope of this line is rise over run, or up and across. The slope of this line is 1/2. Just looking at this, what's this slope going to be? We know it's going to be negative, right? Let's make our right triangle first. So we go 1, 2, 3, 4, 5. So we go down 5. And 1, 2, 3, 4. Over 4. The slope of this line is -5/4. -5/4. I went down 5, over 4. Negative slope, right? It's downhill. It has to be negative. Downhill, negative. Downhill, negative. Uphill, positive. Uphill, positive. All right, let's look at this one. Well, we can't go up or down, right? We can't even make a right triangle. The slope of this line is 0. Remember, that's our definition. 0 effort to go flat. It's 0. Let's make our triangle for this one. I start at this point. Remember, you got to pick a point right in the crosshairs. It's got to be exact. So I go up 1, 2, 3, 4. So I went up 4 and over 1. So the slope of this line is 4 over 1. Rise over run. You got it. These are easy, right? All right. When I yell bacon, you're going to plot these points. And we're going to tell if this line's linear or nonlinear, and then figure out the slope. Bacon! Hey, welcome back. Hopefully you didn't get tricked by this. I plotted these points, right? Negative 4, 5. Negative 2, 2. 0, 0. Uh-oh, then 2, 2. And 4, 5. Is this linear? Can I draw a line there? I can't draw a straight line with connecting all these points. So this is nonlinear. And if it's nonlinear, it doesn't have a slope. Did you get tricked by that? I bet you didn't. Let's do the next one. Number 5, when I yell bacon, plot these points. Find out if it's linear or nonlinear. And if it is, remember, find the slope. And slope, the formula, remember, is rise up. So it's rise. And then run. You got to get out of bed before you can run, right? You got to rise up and run. Bacon! Hey, welcome back. Hopefully you plotted the points and worked this out. You should have 2 answers for this one. Plotted the points. 4, 5, 4, 5, right? Go this way first. Remember? 4, 5. 4, 5 is there. 3, 2 there. 2, negative 1 there. And 1, negative 4. Perfect. I can draw a line there. So that answers our first question. Is it nonlinear or linear? Well, it's linear, right? I can draw a line. For slope, it doesn't matter which 2 points I pick. I'm going to get the same answer. So I draw my right triangle. 1, 2, 3, 1. So I rise up 3, and I run over 1. Rise up. So my slope of this line is 3 over 1. I'll show you it doesn't matter which points I take. I'll do this one. 1, 2, 3, and 1. Rise up 3 over 1. It doesn't matter which points on this line I take. I'm going to get the same answer because it's linear. Linear means line. It doesn't matter which points I take. I could even miss it, right? I could go 1, 2, 3, 4, 5, 6. I could go from here to here and over 2. Well, 6, rise up 6, run over 2 is the same as that, right? Yep, it's just a reduced fraction. So it doesn't matter which ones I use as long as I use the ones that are right on the point, right in the crosshairs. Find the slope of this line. Well, one, is it linear or nonlinear? Looks like a line to me. Linear. Now, let's pick points that are exactly on the line, exactly in the crosshairs. I'm going to pick this point, and I'm going to pick this point. I know what you're saying. Mr. Carr, you missed that one. I know. I'm just proving to you that it doesn't really matter. So I'm going to go up 1, up 2, right? I'm going to make my right triangle. Remember, right triangle has a right angle in it. And from here, I know my slope's positive, right? I go up 1, up 2. My rise up. Slope is rise over run, right? Rise over run. I go up 2. And I go over 1, 2, 3, 4. I can reduce this fraction. The slope of this line is 1 over 2. I rise up 1 and I run over 2. So I could have used this point, right? Up 1, 1, 2, up 2. It doesn't matter what 2 points I pick on the line. I'm going to get the same answer no matter what. Slope, rise over run. This is the end of part 1. There's some IXLs and some exercises you can work through. Have a great day, math fans.